The second part of this series on Oracle 23 AI. In this, we are going to see how Oracle Vector Database search works. So now, what is lexical search? Lexical is an exact text search. So consider this table, ID and text, where in text you have Dubai, Emirates, UAE, and so on. Now, if I want to see what are um, columns or rows similar to Dubai, I might just give in this SQL, select star from table where text like Dubai. Now it might give you only one row, right? But I want to know what are the rows which are like Dubai. It could be anything related to Dubai. Ideally, I should have got Dubai, Emirates, and UAE. But conventional lexical search won't give me this result. So that's where vector search comes into play. To enable vector search, I just added a column here, v underscore text, and the format is vector. Just like you have number var2, I will have to define it as a vector. Now, for simplicity's sake, let's assume that this vector is of 2 dimensions. Now, just imagine it being represented in the graph. Now, since it is 2 dimensions, it's easy to represent it in an XY axis. So Dubai will be here, Emirates will be 2, 2, UAE, and so on. So these are represented on a XY axis being 2 dimensions. Now, how it works here is that I fire the command select star from the table order by vector distance. Now, here I have hard coded 1, 1, which is Dubai. This is the search mechanism or the way the distance is calculated, and I tell it to fetch the first 3 rows. Now, what will happen is Dubai, Emirates, and UAE will come in because they are the closest in terms of their coordinates. Now, how do I vectorize it? The 1 comma 1 2 comma 2, how is it? So that's where there are multiple models. You can do it either internal or external. Internal means within the DB. So what happens here is that Oracle uses Hugging Faces model in ONNX format, which is a neural network format. So this file in .onx you just drop it into a directory which you have predefined it. In my case, I have defined it as a model underscore dr. So you drop that .onx file and then name this model, and then once you have loaded the ONNX model, you can use that in your query. So you update the same table, use the command vector underscore embedding. This is the model name using text, which is your column as data. So what will happen? You will be able to update the vector column with the coordinates 1, 1, 2, 2, and so on. The other way is to write probably a Python or a JavaScript and call external embedding models like BERT or Cohere or GPT's model, and that's another way, but obviously you will be sending the data out. So internal is probably the best way to go about it. Now the question arises, how do I calculate the distance between these vectors? Now there are multiple ways. Euclidean distance, which is the straight line distance, you have Manhattan, you have Minkowski cosine, and then a host, a lot more ways to find out the distances. Now it may look pretty easy, but here we have taken the most simple example of 2 dimensions. There could be multiple dimensions, making it more complicated. The other terms are exact search and approximate search. Now exact search means that if I have to find out things which are similar to Dubai, I have to find out the distance of Dubai with every other object here. Now that's going to be time consuming if there are multiple rows in the table. That's why we have approximate search using vector indexes. Now, vector indexes is not similar to the normal index which we are used to. We have a couple of types of famous vector indexes, but we'll not go into it. So you can do an approximate search which gives you a kind of 80 to 90% accuracy, but it's much faster. So I logged into this 23AI database. So this is the table. I'll select this table. I'll get the rows which I had pre-populated it, Emirates, Dubai, UAE, Delhi, and so on. The vector column I had added it through this command, vector 2, float 32. 2 is the number of dimensions in this example. Float 30 is how it is represented inside the DB. Now, since I don't have access to either the internal or the external models, I'm going to just update it. I just hard-coded the vectors. So once it is updated, you can see that the vectors are now updated in the vector column because float, that's how it's represented. And now I can do the select from this table. 2 comma 2 is what is Dubai. So let's see what are the five, or let's say what are the three nearest neighbors to Dubai. And here you go, Dubai, Emirates, and UAE. Now I can just try to make it as five so you can see the results. So Sharjah comes in, and then you have Muscat. So Muscat, technically, while not in UAE, it's the nearest neighbor. So that's why Muscat also comes in. You can combine it with adding normal column as well in your VAT clause. So this also works fine. So you can see here how we are able to combine vector search along with normal traditional columns. Now, to make it more complicated, you can think of complex sentences, images, videos, audios, books being vectorized. You think of dimensions, not just of two dimensions as shown in the example. The number of dimensions can go to be 500, 1024, or Oracle database supports almost like 65,000 dimensions. Complex methods of approximate searches, which we spoke about. So it's not as simple as depicted in the example. What are the use cases? Plenty of use cases. You have the recommendation systems which comes up in Amazon or in Netflix, which tells you the recommended films to see or the products to buy. You have image and video searches, or it could be audio search. You have natural language processing, anomaly detection, and probably the most important one is the RAG-based applications, wherein you use vector search in your local DB to augment your prompt when sending it to the global LLM. Thanks for being with us. In part three, we're going to have a look at the JSON relational duality, an important feature of 23AI. Thank you.